So as we move forward, let's remind ourselves with the key steps that we have to go through. As you remember that we have imported our required libraries, we loaded the dataset, we performed some exploration, data analysis techniques, and we visualize data and understand its structure. We checked for the missing values, outliners, and we understood some of the relationship between the variables. Please feel free to construct more further analysis for the features that you think that they might have, a potential feature selection on the target variable on when building your predictive model. We try to pre-process the data, but since we haven't have any missing data or any categorical features, um, as you recall that I've showed you how you can, fill the NA with the median or the mean or min and max. I've showed you also how you can drop these values or replace it with a specific value. So now we are at the fifth step here, when to train and test, split the data into training and testing sets using the train and test split from the scikit-learn. To remind you that we have already imported the library needed, so I don't think so that we need to recall it. So now let's move directly to the coding part. So as I mentioned, let's now split the dataset into feature variables where you have seen, the gender, the chest pain, all of these, we call them features, and the target variable where y. Y means it's 1 or 0, where it's representing the positive and negative cases of the heart disease. So we'll try first, let's comment this out by saying split the data into x and y. Simple as can, write x is equal to data frame dot drop, and let's put our target and where the axis is equal to 1. Let's close that now. And y y is equal to the data frame, which is the target variables. Target variable. Okay. Again, just to explain this in more detailed way, so the data frame dot drop and target axis 1, it will remove the target column from the data set, which we have in our case is DF in our data frame, because the target column is what we are trying to predict. So the remaining columns are the features variables that we will use them to train the model. The axis is equal to 1. It's an argument that indicates that you want to drop the column, not the row, okay? So X will be the data frame containing all of the feature variables, as I mentioned, like the age, the gender, the CP, and the cholesterol level. So the process of splitting the data into X, which in our case the features, and Y, which is our target, is essential because it allows the model to learn the relationship between the features and the target. Also, it will help us, or it will enable us to pre-process the features and targets separately, as well as you will see it later how we can, it will provide us like a clean structure to train and evaluate and test the model itself. Let's execute this code and then see how will our data frame look like. Let's now try to find X. Let's run X. As you could see that the, the target variable is no more exists within our X dataset. Let's now see the Y. As you could see that it only represent a binary classifications, only 1 and 0, where 1 is equal to heart disease and 0 equal to no heart disease, with a total of 303 rows. So now we have successfully separated our or splitted our data set into the features variables and the target variable, and we call it under X and Y. Now after that, we have created a new data set by splitting our data set into X and Y. So X, we say that it contains the feature data set, and the Y data set, which contains the target data set. To remind you why we have done that, because it allows the model to learn the relationship between the features and the target, and it enables us to pre-process the features and target separately. Next, we are gonna also split our data and create a new data sets that contain our training data and testing set. This is also a crucial step when building a machine learning model, to ensure that your model is trained on one proportion of the data, and also it's evaluated on another proportion of data, or we call it as the testing unseen proportion. So the breakdown of how we are going to do that. So first we'll train it to find the patterns on the training set, and then we'll test it on the testing set to use the patterns that has learned from the training data set. So let's start coding, and then I'll again explain it in more detailed way. Let's start doing our comment split data into training dataset, also string dataset. We'll first set this random seed, random dot seed. I'll set that to 42. I'll tell you exactly why we're using this code later. Then now let's use this as xtrain. And then we have xtest. We'll also have the ytrain or ytest, ytrain and ytest. Then y test. That is gonna equal to trend test split, which is a function from Scikit-learn. We have X and our Y dataset that we just created now. And let's specify the testing size to be at 0.2, which means 20% out of your data is gonna be as a testing data. Testing size is equal to 0.2. Let's run this code now. Okay, just to recap on the code that we have written here. So first we start by setting a random seed, and that is used, to set a fixed random seed for the reducibility. This means that every time you run this code, you will get the same split of the data. The number 42 can be any integer. It just ensures that the random operation, like splitting the data, give you the same results across different runs of the code, which is important when you want to compare the results or debug your model. The next function that we used is the trend test split x and y with a portion of 20% as a test size. So the third test split is a function from scikit-learn that randomly split the data into two subsets containing the training set and the testing set. So in our case, we have x. X is the set that we created, which contains the set of feature variables, the input variables also, we call it. Y is the target variable where the labels or the output data you're trying to predict. The test size 0.2, which specify 20% of the data should be set aside for testing, and the remaining 80% will be used for training to find the patterns within the data. You can change the value based on how much data you want to reserve for testing. Some people also, as I mentioned before, you might face people who has three different data sets. So they do it as 70% for training data set, and they use 15% for validation data set and 15% for testing data set. So it's up to you how you can use it.